What we have here for the demo is when we breed either on the male or the female side genetically, because we need them to be unrelated so they make good hybrids. So here we have both of these inbreds are still popular in the seed industry. The one on the left sells a lot of silage corn in France actually now, and sells about a couple 100,000 units of silage a year. The one to the right, the next two rows 3 and 4, is sold commercially here. They're different in that obviously you can see one has pretty good roots, one has terrible roots. The parent one, the outside 2 rows, rows 1 and 2, are white cob, hard grain, poor roots, upright leaf structure, sits at about 105 to 108 day, makes a wonderful seed parent, but very hard grain, no denting. The parent line here, rows 3 and 4, parent 2, has wonderful roots, is short in stature, delivers that shortness to the hybrids, has really deep kernels, and combines with only a few things. Parent 1 will combine with lots of different males, make lots of different hybrids. Parent 2 likes about 2 things, and they're very specific to each other. To make a breeding population, we want to try to improve the roots on parent 1, but we would like to maintain the grain quality of parent 1 and not let parent 2 take it down. So we want to find that midpoint of those 2 crosses together. If you're doing cattle breeding or you're doing chicken breeding or whatever breeding you are, it's about herd management. What we have here is a set of materials, and every one of them came from this cross. So we cross these 2 related parents together. We take pollinating bags such as this, and we control the pollen from a tassel and put it on its own silk. So it'd be like you running bin run corn. This is what your bin run seed would look like the next year, wild and several combinations of the genes of the 2 parents. When we do this, we can look down here, and I need this stick. I'll get all tied up here. Thank you. So when you look at these roots, you can see this fusing down here of these roots. There's a chemical reaction to what Phil put on this field. You'll actually see that, and you'll see that we have has it on every plant. We have a coloration of roots over here on the poorly rooted one. If you look over here, we've got red stalks with green roots, red stalks with red roots, green stalks with green roots. And at pollinating time, we came out and we are marking the plants. This plant pollinated on the 29th of July, and it had a pink tassel. Parent 2 has a pink tassel. Parent 1 has a white tassel. So we're causing segregation. These stalks are really a problem. There we go. As we go along, we had a white tassel also on the 29th. I only came down here for a day or 2 to make these. But what you get is a combination of things that lets you select through there for the types of characters you want. Now, as a display, Jerry Broders and I went out today and just walked through here in these 10 rows or 12 rows, and we just randomly picked ears. This is parent 1, white cob, hard grain. This is parent 2, deep kernels, dented. And then all of these ear types are the segregates that are coming from that display, from the genetics of combining these 2 parents. So you can't really predict what we're going to get, can we? We know that what we're looking for is to get better roots, and we want to maintain this grain quality. We like this kernel depth. I kind of like the white cob because we're probably going to get some silage work out of it. But look at the variation we have. Hard grain, white cob, hard grain white cob, hard grain red cob. They look exactly alike, do they not? But we segregated on the cob color, which means we probably segregated on tassel color. We probably segregated on root color. Let's see if this will sit there for a second. If you're looking at this grouping of plants and you think about that graph that we showed when we were in Des Moines, and all the plants fit inside this population, we have plants over here that are more like parent 1, and we have plants over here that are more like parent 2. In the middle would be the perfect midpoint. Now you can actually see it, Chris, if you go back there and look at that bag 30 right there, and you look at that plant, you've got a combination of the roots from parent 2. That tassel up top above you is a dead-on match to parent 1. Those leaf structures matches parent 1. If you pick that bag up and husk that ear back for me, what color is the cob? It's white, parent 1. But that grain is like parent 2 on that first board, right? That grain looks more like this one. So we have a nice combination. It's vigorous. As we continue to self, and we do that selfing from the tassel to its own silk 4 or 5 more times, those plants will come down with inbreeding depression and they'll start to achieve this height. About 4 times through the selfing, we start to cross them up with parents, unrelated parents, to make hybrids. We send them through trialing systems and say, okay, number 47, the 47th ear makes a better hybrid than the 46th ear, for example. So what we're trying to do, and we showed those funnels when we were in Des Moines, when we make a population like this, the first thing we want to do is we want to say we want corn that's earlier. We want the late yield genetics into the earlier germplasm. So we take a cut and we look at only these plants that are on the early side of flowering, right? Then if we take it and we do it again, we might take that grouping of plants, put it through another funnel again, and we might say we want the ones that have the test weight or the roots or the combining ability of parent 1 or parent 2 or whichever way you want to. By the time a new inbred line comes out from that cross, we'll be 4 years down the road. It'll have been to Mexico or Chile or Hawaii 3 times. It'll have been in yield trials near your farms, around your farms, in our testing system in different hybrid combinations. And by the time we come out with a final inbred line, it may have been tested. Test cross with maybe 5 or 6 different males, trying to find the best male and the best hybrid that it can have. But we're looking for those traits that came through that funnel, deciding which ones we're gonna make. If we take and test cross this the first time, and we've got the early plants, and we wanna say, we're after roots. Remember, this was about roots when we started off. We're gonna cross it with a weak-rooted male so that it exposes the weaknesses of these. We're not about yield at that point. We wanna call out the roots. It's another funnel. We get that funnel of weak roots, get that done. Then we say, okay, now these are the ones we want to see if they'll make hybrids or not. So the second cross, the third cross, that's about yield. Can we get it dry? Can we get it to come down and be drier than parent 1 by its cross or parent 2 by its cross? And we use those as checks. 4th time we start crossing, we've identified what we like, and we start putting it against John's lineup. And we go, can we beat 5742? Can we beat, which is the one you like? Yes, that one. Right? And so we'll have a new trumpet. Does this make sense? Questions?
You know, we've a lot of talk about tar spot in the industry.
Yeah.
Maybe you want to talk about what we're doing, what you're doing in eastern Iowa and Wisconsin for tar spot and kind of the program, what we're doing breeding there.
Yeah, so since John and I have been working together, which is coming up on 7 years, we've been noticing tar spot in Wisconsin. Well before you all started talking about tar spot, we were getting tar spot notes. We've always had a location at Platteville, Wisconsin. You know where that is? That'd be east of Dubuque, about a half hour, 45 minutes. So we put a huge plot out there. Every hybrid Lyle has, every experimental Lyle's talked about, and everything we're using in the breeding program is in that plot, waiting for tar spot. So Michelle and I have made 4 or 5 trips over there hoping for tar spot. You don't do that in your life. Hoping for tar spot. And the last meeting we were over there was 10 days ago, and we had tar spot throughout the plot. And the farmer's field around us, a DeKalb hybrid, was loaded with us. We got great inoculum. So we're looking forward to another 2 weeks from now, we'll go back, and 3 or 4 weeks from now, we'll go back and we'll start rating. But the thing we did that I don't think most people have done, we put all of our inbreds over there too. All of those lines, which are in the hundreds, are all over there being evaluated for their susceptibility or their reliability against tar spot. There isn't resistance yet in the breeding program. Doug, our new breeder, did pick up 2 new versions of resistance to tar spot. One's from Mexico and one's from Cuba. They're sitting on my desk back in South Dakota, and they'll be going into the Mexico nursery this winter as we start to bring it into life. We can't plant it here. It's daylight sensitive to South America, so we're gonna have to go Chile, Argentina, Mexico with it until we get it combined with our stuff so that we can bring it in and it'll flower here. But we have the resistance genes accordingly, and if it holds true, then over the course of time we'll get that developed into our program. Good question, sir. Wisconsin for tar spot has become a very important conversation piece for us, and we're doing something about it anyway. All of the commercial checks that we use in our trials are there too, DeKalb and Pioneer and such. So
Phil said he's found tar spot out here this morning. I'm not sure where.
I wouldn't doubt it. With the cool nights, I don't know how many of you guys are up really early in the morning, like probably most of you, but 5, 6 o'clock in the morning, like this morning, it was 61 degrees this morning and wet. And that's been going on now for what, 2-3 weeks? This is perfect. That's perfect for northern corn leaf blight and gray and tar spot, if your leaves aren't too old, right? So some of this later planting corn that some of y'all have could be kind of susceptible to being a target spot for all of those things. So probably too late to do much with fungicide on it, but not too late to get a reading on what we can do. So we're happy about it because the farmer that we're working with is going to get a good dose of tar spot, but his crop's made. He's not going to get damaged, so we'll get our analysis off of it and come back again next year for it. Thank you.